Life on Earth began more than 3 billion years ago, evolving from the most basic of microbes into a dazzling array of complexity over time. But how did the first organisms, on the only known home to life in the universe, develop from a primordial soup? One theory involved a shocking start. Another idea is utterly chilling. And one theory is out of this world. Since its inception in 1924, the primordial soup theory has gained a firm following in scientific circles. The theory states that a young Earth possessed a reducing atmosphere, and following exposure to various forms of energy, basic compounds were formed. These compounds were then said to have accumulated in a soup from which life evolved. The big question this leaves is, how and why did life evolve from this collection of simple elements and compounds? How did it start? Ultimately, the question revolves around abiogenesis, which is the process of which a living organism forms naturally from non-living matter. Here is a list in no particular order of 7 existing theories for this initial abiogenesis, and an exciting new one. We will be looking at how life developed on Earth. In this video, you'll learn just how mysterious this all is, as we reveal the different scientific theories on the origins of life on Earth. But before we begin, do subscribe to Idea Haven, give this video a thumbs up, and comment down below if there's any other topics that you'd like us to talk about. It started with an electric spark. Lightning may have provided the spark needed for life to begin. Yes, there is a theory that life on Earth began Frankenstein style. It has been proven that electricity can produce simple sugars and amino acids from simple elements in the atmosphere. This leads to the theory that lightning may have been responsible for the origins of life, primarily by striking through rich volcanic clouds. Electric sparks can generate amino acids and sugars from an atmosphere loaded with water, methane, ammonia, and hydrogen, as was shown in the famous Miller-Urey experiment reported in 1953, suggesting that lightning might have helped create the key building blocks on life on Earth in its early days. Over millions of years, larger and more complex molecules could form. Although research since then has revealed the early atmosphere of Earth was actually hydrogen poor. Scientists have suggested that volcanic clouds in the early atmosphere might have held methane, ammonia, and hydrogen, and been filled with lightning as well. Or could simple clay have fueled life's beginning? Molecules of life met on clay. Research at the University of Glasgow in Scotland has given rise to the theory that life on Earth may have evolved in clay. It is suggested that clay may have served as an area of concentrated chemical activity, providing a breeding ground for DNA and other components. These surfaces might not only have concentrated these organic compounds together, but also helped organize them into patterns, much like our genes do now. The main role of DNA is to store information on how other molecules should be arranged. Genetic sequences in DNA are essentially instructions on how amino acids should be arranged in proteins. Karen Smith suggests that mineral crystals in clay could have arranged organic molecules into organized patterns. After a while, organic molecules took over this job and organized themselves. Life began at deep-sea vents. Submarine hydrothermal vents, or deep-sea vents, contain vast and diverse ecosystems. The nutrient-rich environment filled with reactive gases and catalysts creates a habitat teeming with life. Studies suggest that life may have originated from within these vents, a theory that cannot be ignored, and one that may in fact tie in with the ice theory. The deep-sea vent theory suggests that life may have begun at submarine hydrothermal vents spewing key hydrogen-rich molecules. Their rocky nooks could then have concentrated these molecules together and provided mineral catalysts for critical reactions. Even now, these vents, rich in chemical and thermal energy, sustain vibrant ecosystems. Life had a chilly start. Ice might have covered the oceans 3 billion years ago, as the sun was about a third less luminous than it is now, scientists say. This layer of ice, possibly hundreds of feet thick, might have protected fragile organic compounds in the water below from ultraviolet light and destruction from cosmic impacts. The cold might have also helped these molecules to survive longer, allowing key reactions to happen. The answer lies in understanding DNA formation. Ribonucleic acid, or RNA, is today most known for its role in the expression of genes. To put it simply, DNA unzips, revealing the necessary gene that is being called for by the body. Then RNA is transcribed from single nucleotides, copying the revealed segment for gene expression. This theory states that all life sprouted from a complex RNA world. This is plausible, as RNA is far more self-regulating, if less efficient than DNA. Nowadays, DNA needs proteins in order to form, and proteins require DNA to form. So how could these have formed without each other? The answer may be RNA, which can store information like DNA, serve as an enzyme like proteins, and help create both DNA and proteins. Later, DNA and proteins succeeded this RNA world because they are more efficient. RNA still exists and performs several functions in organisms, including acting as an on-off switch for some genes. The question still remains how RNA got here in the first place. And while some scientists think the molecule could have spontaneously arisen on Earth, others say that was very unlikely to have happened. Other nucleic acids, other than RNA, have been suggested as well, such as the more esoteric PNA or TNA. Life had simple beginnings. In contrast to the RNA theory, this approach suggests that the primordial soup simply continued to react with itself over time, producing more and more complex molecules, eventually yielding life. This is the most simple of the standing theories and is difficult to dismiss. Instead of developing from complex molecules such as RNA, life might have begun with smaller molecules interacting with each other in cycles of reactions. These might have contained in simple capsules akin in cell membranes. And over time, more complex molecules that perform these reactions better than the smaller ones could have evolved. Scenarios dubbed metabolism first models, as opposed to the gene first model of the RNA world hypothesis. Life was brought here from elsewhere in space. Perhaps life did not begin on Earth at all, but was brought here from elsewhere in space, a notion known as panspermia. Panspermia is the proposal that life on Earth didn't actually begin on Earth at all. Rocks and other debris from impacts are plentiful. In fact, rocks from Mars could have been found here on Earth, and it has been suggested that any one of these would have brought microbes that could have kick-started life. So, would that make us all aliens? For instance, rocks regularly get blasted off Mars by cosmic impacts, and the number of Martian meteorites have been found on Earth that some researchers have conversely suggested brought microbes over here, potentially making us all Martians originally. Other scientists have even suggested that life might have hitchhiked on comets from other star systems. However, even if this concept were true, the question of how life began on Earth would then only change to how life began elsewhere in space. Now we know we mentioned that there are only 7, but there is sort of a new theory that is making wave, so don't go just yet. The newest addition to this mix of theories has been clearly articulated by the Massachusetts Institute of Technology in the USA. The contention from supporters of this idea is that life evolved out of necessity, following the laws of nature, rather than through any accident or freak occurrence. In a number of papers, physicists have argued that the occurrence of life is a matter of inevitability, and that they have a sound formula to support their claims. The new models that physicists have come up with are formulated on previously established theories in physics, and they conclude that matter will generally develop into systems that, when driven by an external source of energy and surrounded by a heat bath, become increasingly efficient at dissipating energy. Studies have shown that populations of random atoms, when exposed to energy, will shuffle and organize themselves to dissipate energy more efficiently. It is suggested that this remodeling would eventually lead to life. So, this new theory may be viewed as an addition to the simple metabolism and reaction theory above, but with energy such as is provided by the sun as the catalyst. This theory was touched upon by Charles Darwin himself, but was dismissed. However, the new research from MIT is backed up by mathematical and scientific evidence. Only time and further research can truly tell if there really is any energy to these claims. What do you think about all these theories? Do you maybe have a theory of your own? Tell us about it in the comments below. If you like this video, don't forget to give it a thumbs up, comment down below, and subscribe to Idea Haven. And while you're at it, hit that notification bell so you're always updated whenever we have new uploads.